You are welcome to today's lecture. This is our third lecture in Chemistry 205 in Organic Chemistry. I welcome you, Fatima. I welcome you, Uzoma Christiana. I think you are attending the class for the first time. You are welcome. Are you along with me? Hello, Uzoma Christiana, Silas. Are you along? Okay, you are welcome. This is Chemistry 205, Inorganic Chemistry. This is our third uh, lecture in this very particular course. You are welcome. We'll be looking at Unit 2, the elements of Group 15, or in some books you find it as Group 5. This group of elements comprises of nitrogen, phosphorus, arsenic, antimony, and bismuth. They exhibit a gradation in their physical and chemical properties in the group. Nitrogen, as commonly known, is a non-metal. Arsenic and antimony are metalloids, while bismuth is actually a metal. Let me try to share with you from the screen. Have it. The slide you have before you is a slide showing the various elements of the group with atomic numbers 7, 15, 33, 51, and 83 respectively. All members of the group have a common electronic configuration, that is NS2 and NP3 in their outer shell, where N is equal to the principal quantum number, and the nitrogen family is located in the P block of the group 2 of the periodic table. Nitrogen shows some exceptional properties. It is a major component of the atmosphere, which we are aware of. And nitrogen and phosphorus are essential constituents of all plants and animal tissues. Slide 2 tries to present to us the chemistry of nitrogen, sorry. It is present almost in all proteins and plays important roles in both biological and industrial applications. Nitrogen forms strong bonds because of its ability to form triple bond with itself and other elements. Therefore, nitrogen, there is a lot of energy in the compounds of nitrogen. Before 100 years ago, little was known about nitrogen, but nitrogen is commonly used as a preservative for foods and is also used in fertilizer, and sometimes it is actually used in explosives. Now, phosphorus. Phosphorus is also an essential part of life. Without phosphates in biological molecules such as ATP, ADP, and DNA, will not be alive. Phosphorus compounds can also be found in the minerals in our bones and also in our teeth. It is a necessary part of our diet. In fact, we consume it in nearly all of the foods that we eat. It is quite reactive. The quality of the element makes it an ideal ingredient for matches because it is so flammable. It's very, very flammable. So it's mostly used in making of matches. Now, how do these things occur in nature? We'll try to look at them later. But let's also try and look at the chemistry of Arsenic. Arsenic is situated as the 33rd spot on the periodic table. It is next to germanium and selenium. It is known for a very long time, and it is first isolated. It is first isolated about 20, 50 years ago. It is classified as a metalloid. That is, it can exhibit both metallic and non-metallic properties. It has a pigment. It is a pigment that is a yellow ointment that is found in most of the other items. The chemistry of bismuth also, which is the heaviest non-radioactive elements that occur naturally on its own, and it is isolated by Basil Valentine in 1450. Bismuth is hard, it is brittle, it's a metal with an unusual low melting point of around 271 degrees centigrade. As alloys of bismuth, they have low melting points, such as in tin and lead, and have lower melting points and much more lower as they are used in electrical solders, in fused elements, and in automatic fire sprinklers. Uh, their physical properties. All the elements of the group, they exhibit polyatomic state. They exist in polyatomic state. That means that they exist in linkage with with themselves and many other atoms. The first element, which is nitrogen, it is a gas, and there is significant increase in metallic character as you go down the group. Nitrogen and phosphorus are actually non-metals or metalloids. Nitrogen is a non-metal, phosphorus is metalloid, acid antimony are metalloid, and bismuth is a metal. This actually attribute leads to the decrease in ionization energy as you go down the group, because as you move down the group, there is increase in the size of the atom, and the electrons that are bounded are far, far away from the nucleus. Hence, there is ease of release of electrons as you are moving down the group. Therefore, the elements, as you go down the group, they increase in size, so they can easily release out electrons, and that's why the energy that is involved in the removal of the electrons is actually less as you go down the group. But across the period, that is in the horizontal axis, there is an increase in the ionization energy. Reason being that the atomic shell remains the same. The more the number of electrons that are actually being added, the more the nucleus pull on the outer shell of the electrons. So the more the electrons are actually bonded together to the nuclei of the atom. Therefore, as a result of that, it becomes a little bit difficult to remove electrons from the shells of the atom. That thereby increases the ionization energy as you go across the period. It also suffices to say that as you go across the period, the size of the atom actually decreases as well. And because of the decrease of the size, the electrons are more bounded to the nucleus. And because they are more bounded to the nucleus, it will require more energy to be able to release them out. That now has to do with the issue of reactivity. Now, because of ease of release of electrons as you go down the group, it means reactivity actually increases down the group. The electrons that are heavier react much more faster because the outer electrons are loosely bound to the nucleus, and therefore they can easily give out the electrons in order to undergo reaction with other atoms that are or ions that are actually present. Meanwhile, as you go across the period, because the size decreases, the electrons are more bounded together. So the reactivity decreases as you go across the period in the periodic table. Now, if we talk about occurrence, nitrogen is the most abundant uncombined element accessible to man. It's around 78.1% of air by volume. If you look at the composition of air, nitrogen takes up here about 78.1%, but it is relatively less abundant in the rocks and in soils of the earth. It is mostly found actually in the air. You can rarely find it in rocks, unlike silicon and the rest of those odd and carbon. You can also rarely find it also in the soil, unlike silicon, which is the major component of the soil. It is about 0.11% present as in the soil or in the rocks. All its non-terrestrial minerals are orthophosphates. The minerals formed of nitrogen are orthophosphate, and it is found as sulfate, that is in potassium nitrate, or sodium nitrate. That's where it's actually, where in most of the cases where it is found. Phosphorus is the element, the order of, is the next element in the order of increasing abundance, particularly in rocks. The major mineral of the phosphates family are carpatides, that is calcium phosphate, Ca5, in bracket PO4 close bracket 3X, where X is actually a halogen, either chlorine, fluorine, and the rest of them is actually a halogen. Or you can have them in chloropatide. Chloropatide are phosphates of chlorine, calcium phosphates of chlorine. That's why they are called chloropatides. You can also have fluoropatides. The fluoropatides are the calcium phosphates of fluoride. That's why they are called fluoropatides. Phosphorus, as is present, it is present in bones and also present in teeth. Arsenic and tin and bismuth are comparatively less abundant in the ash crops. They mostly occur actually as sulfides. You can find them as sulfides. And their normal extraction procedure sometimes can be a little bit rigorous. Take for example, nitrogen is obtained on commercial scale from air, from destructive distillation of air. That means nitrogen is cooled to remove the water vapor and carbon dioxide, and then it is rapidly compressed to about 2 times 10 to the power of 4 kappas and allowed to expand rapidly. This causes the temperature to fall down very, very low, and eventually the air is liquefied. Now it is used in the liquefied form and into cylinders. So the fractional distillation of liquid air enables the separation of nitrogen, oxygen, and the noble gases, because these are the major components of air, or the elements that are actually found in the air. So when you carry out the fractional distillation of the air, you can be able to separate the various components, or the different components, which are nitrogen, oxygen, and the noble gases. Phosphorus is extracted from phosphate rock by heating it with sand and coke in electric furnace at a temperature of about 1800 degree Kelvin. The non-volatile silicon dioxide displaces the more volatile phosphorus pentoxide, which is then reduced to coke. Coke is what you actually call as a good air. Let me pause here again and try to share with us some content of our of the slide we have. So what we have there, some of those things are the physical properties of the elements. The next slide 9, it talks about the chemical properties. That is their valence shell, that is of the p block elements. They have a configuration of ns2 np3, as I said earlier. So the elements here can either lose 5 electrons or they can gain 3 electrons in order to attain an octet configuration. Octet configuration, that means having 8 electrons in the atomos shell. And almost every electron seek to attain the octet configuration. The reason being that as long as the outer configuration of the element is not complete, the element is uneasy, the element is unstable, the element appears not complete. So the element either seeks to lose its electrons or to gain electrons in order to attain a complete outer electronic shell. And this is mostly done through reaction. And that's what led to the formation of either electronic bond or covalent bond or coordinate covalent bond, which we will be looking at in our uh, next classes. The common oxidation states of these elements are -3, +3, and +5. And with decrease in the ionization enthalpy or energy down the group due to increasing atomic radius, the tendency to gain these electrons to create a -3 oxidation state decreases down the group or as you go down the group. Bismuth hardly forms any compound with -3 oxidation state. Arsenic, as we go down the group, the stability of +5 also decreases, and that of +3 increases due to the inert pair effect. Now, inert pair, because you have the NS2, NP3. The S2 are paired electron. So it gets to the level that those two paired electrons are resistant to reaction. They are resistant to the unpairing. So the available 3 electrons in the p orbital are actually the electrons that are available for bonding, that are available for reaction. And that's why the +3 oxidation state increases as you move down the group. The next slide, the next thing we have is to look at the uses of some of these elements. Nitrogen, as we said earlier, is used to create an inert atmosphere in iron or steel industry and in many other metallurgical and chemical processes where the presence of air will involve fire explosion hazards. So they try to create an inert atmosphere by making sure that nitrogen is made to saturate the area. So thereby making the atmosphere inert and making explosion or reaction difficult. It is also used in the packaging of processed foods and some um, pharmaceuticals, and to preserve some electric uh, cables, telephone wires, rubber tires, like liquid nitrogen, which is used for freezing of foodstuff. So nitrogen has a lot of uses or a lot of advantages, what is actually used for. Now, things like phosphorus, we said earlier, is used in matches. Is one of the major components of making match, the match you use to light fire. It's also used in fireworks. And arsenic, tin, and bismuth are used in the production of alloys. Ammonia, who is a compound of actually nitrogen, is used as fertilizers. And it's also used in the manufacture of ammonium nitrate, explosives like nitroglycerin, nitrocellulose, TNT, trinitrotoluene, and hydrazine. Trinitrotoluene in particular is actually an explosive that is used mostly, particularly in war zone and some other area. The sulfides of phosphorus, like P4S3 and P4S10, are used in match industry. Phosphoric acid is used in fertilizers, in cleaning of metals, in rust proving and pharmaceutical, etc. Now, their general properties, like we said earlier, they have 5 electrons in their valence shell, and they have oxidation state of +5. And down the group, the tendency of inert pair electrons actually increases. And only phosphorus electrons are used in bonding, resulting to an oxidation state of +2. The chemical properties, which we tried to look at earlier, also talks about how they can form, nitrogen can form double bond with itself, or can form nitrogen-nitrogen triple bond itself. In fact, sometimes it serves as a blessing uh, because the atmospheric oxygen may otherwise disappear with some of the nitrogen to form oceans of nitric acid. That's why presence of the nitrogen bonded and being inactive is a very good advantage, so that it doesn't actually act with the other things. While white phosphorus is very reactive, red phosphorus, which is black, is not reactive. And arsenic, tin, and bismuth are actually fairly reactive. Now, there are reasons or purposes for some of these things. As we try to look at some of the properties of these elements, we get to go further to talk about the reasons, particularly like white phosphorus and red phosphorus. Why one is reactive and the other one is actually not reactive. Can Fatima or Uzoma, do you have any question? Are you with me?
Yes, sir. No, sir. No question, sir.
No question?
No questions, sir, for now.
Fatima, any?
Yes, sir.
So if you don't have question, then I'm going to ask you a question. Are you ready?
Okay, sir.
Fine.
Yes, sir.
Why is white phosphorus very reactive and red phosphorus not reactive? Because the two of them are allotropes of one another. Okay, that may be a little bit difficult. What is allotropy? Let me ask you this question. What is allotropy?
Allotropy is an occurrence where
allotropy is what? Yes. What is allotropy? Allotropy is the existence of an element in two or more different forms. It exists in two or more different forms. They still have the same chemical, but differ in some physical properties. But they are allotropes of one another. Now, mention the behavior of nitrogen. Yes, are you with me? Mention two anomalous behavior of nitrogen. Uzoma? Uzoma, are you with me?
With you, sir.
Mention two anomalous behavior of nitrogen. You cannot? Okay, we said earlier that every member of the group, because of its smaller size, it always exhibits different characteristics compared to other members of the group. So nitrogen, being the smallest member of the group, have so many abnormal behaviors if you compare it with other members of the group. Like we said, it can form double bond or triple bond with itself. As you go down the group, most of the elements cannot be able to exhibit that kind of property. Secondly, nitrogen also can be able to exist in its polymeric form. But as you move down the group, as the sizes of the atom increases, bismuth does not exist in that kind of polymeric form. So there are some of those characters which I told us in our earlier class that every first member of the group exhibit characteristics that is quite different from other members of the group as you go down the group. So we must take note of some of those terms: anomalous behavior, allotropy, catenation, and all those things, because these are some of the things that one will want to ask from time to time. So if you don't have any question, I think we may have to stop here until maybe another time when we will have the class again to meet. Right? Thank you.
Yes, sir. Thanks for your time, sir.
Thank you.
Thank you so much. And hello, sir.
Thank you.
Hello, sir.
Yes,
Hello, sir.
I can hear you.
Yes, sir. Please, this is my first time of joining your class. I actually tried to download the previous videos,
Yes.
the 2 previous videos, but yes, I was unable to download it.
Why? Don't you have that?
It's saying, sir?
It's saying what?
It's saying the owner has removed the access to the videos.
No, I didn't remove access to the videos. I will check again.
Yes, sir, that's what.
Okay, I will check and find out if there is any problem. We'll try and rectify that.
Okay, sir. Thanks so much for your time, sir.
By Monday,
God
we'll
bless.
also upload it on the learning environment so that you can also have access to it.
Okay, sir.
All right.
Thank you so much, sir.
Thank you.
Yes, sir. Yes, sir.